Good morning. Today I just want to do a quick little video talking about the difference between pure substances and mixtures, because I know also those kind of come up. So again, a pure substance is something that is only made of one thing. Okay. So for instance, if we have this red dot being a, let's say that's any element, it's just going to be by itself. As we talked about in one of the previous videos, an element is when you have one type of atom repetitive, and that's it. Okay. A compound is when you have two or more elements together that again are repetitive. So it's only made of, say, this one thing. You can see that they're connected. And again, the element's by itself. You'll notice that a mixture is going to be a blend of two or more things. These are independent of one another, and these are also independent of one another. Again, these dots can represent elements, compounds can represent anything, but I think it's a good visual. Obviously, these two are different. Here, because it's a compound, they are combined. Here, they are loose in both types of mixtures. So an element might look like this. As you can see, an organized pattern, it is one type, and that's it. For a compound, again, knowing that this is together, might repeat like that. And again, they might not all be lined up like that. You know, it all might be, I could do something like this, rotating all of them, I could flip them, kind of however I want. But again, that pattern and that repetitiveness is again still there. Fix that a little bit. Now, a mixture is again two or more different things that have been blended together. A homogeneous mixture, again from the root, means the same. Or hetero's root means different. So what you're going to have is a homogeneous mixture. It's going to look the same throughout. So what might that look like? Well, that might look something like this. You can see there's not a lot of kind of the purple pinkish one, but you can see they're kind of blended together nice and equally. This surrounded by some red, this surrounded by some red, this surrounded by some red, this surrounded by some red. So again, it's going to be blended together, kind of evenly spaced. And again, I will show you some examples of food in a few seconds that show that. Whereas a heterogeneous mixture where there's different things, you're going to see that there's chunks. For example, the purple pinkish one, there's obviously a block of them together. There's another block together. You're going to see this as a difference when you're looking at your entire mixture. So what are some examples of that? Obviously, element examples, anything on the periodic table here, compounds, putting some of these together, water, carbon dioxide, salt, anything like that, hydrochloric acid. Here, what would that look like? Well, as foods, homogeneous again, being the same, it's going to look blended. Milk is a bunch of different things. It's blended together. You cannot see the difference. Homogeneous. Tomato soup, again, blended mixture. Can't tell the difference. Coffee and cream, another really good example of that. Okay, can't tell the difference, especially once it's stirred. Heterogeneous, you're going to be able to see those different parts. Salad, lettuce, blue cheese, chicken, tomato, maybe crunchy onion, plus dressing if it's salt, pepper if you can see it. Milk and cereal, obviously you can see the milk, the cereal, the almonds, the strawberries, the blueberries, granola, everything kind of going on there. And again, one of my personal favorites, nachos. I think I can leave it at that. So again, another really good way to kind of look at it is, again, I like this picture. Again, homogeneous, you have coffee, cream, and sugar. If it's all blended together and you can't see the ingredients, it's going to be homogeneous. And again, if you can see like visible lumps of sugar, milk, and sugar, probably curdled, old, gross, that's going to be heterogeneous. So there's just a little bit of a difference between pure substances and mixtures and hetero versus homogeneous compounds.